guys, and then welcome to another video in this playlist. In this video we'll be looking at questions on probability density function. So there are a series of questions here we'll be looking at, starting from what we have over here. It says show that the following functions are probability density functions for some value k and determine the value of k. We'll be looking at the first one, which is k x squared for the range of values x greater than 0 but then less than 4, and then 0 L squared. Now for this question we'll be solving the A in this particular video, then in our subsequent videos we'll look at B, C, and then D. So without much ado, let's quickly go into the question. Now in solving the question, I'll try my very best to give a visual representation of what the function looks like. So the question has asked us to consider this function, right? And our task 1 is to verify that f of x satisfy the condition of a probability density function. And then secondly, we have to determine the value of k. So this is just a visual representation of what the function looks like. This is f of x, right? This is kx squared, even though we don't know our value for k, but then this is how it will look like if we are to input it in a calculator. So now that we know how it looks like, let's quickly go into the verification. Now, so the function we have been given, f of x, is equal to what we have over here. Right? Now it is important to note that if we have this type of functions, that is f of x being equal to k x squared, all right, x squared alone is always greater than 0 for every x that is greater than 0. Hence this implies that if we are going to get a k that is also greater than 0, then it would imply that our f of x, which is this over here, this f of x, this one, is also going to be greater than 0, right? It is also going to be greater than 0. Hence we can say that the function f of x is non-negative for 0 less than x less than 4. Hope it's understandable. All we are trying to do is, the first condition, we want to verify that this function here is non-negative. What this means is any value we put within a range should give us an answer that is not negative. So we are saying that if we take only x squared, this one here, out of the whole function, that one alone gives us values that are non-negative. You see, especially even for values of x that are greater than 0. Look at the values we have over here: 0, 1, 2, 3. So it says greater than 0, so the values will be 1, 2, and 3. You see, and they are all greater than 0. Hence this function x squared alone is greater than 0. Now we are done with the first part, which is x squared. Then we come to the constant, and we are saying that if the constant as well is greater than 0, then it will mean that our function, the whole function, would then also be greater than 0. You see, so hence we've been able to verify. Now the next thing we have to do is to determine the value of k. We are now to determine the value of k. So our function, once again, we all know to be what? F of x right. Now we have to apply the normalization condition. This is what we call the normalization condition. So we are going to normalize it. What this means is, if we find the integral of the function, right, we should get it as 1. If we find the integral of the function with these limits, we should get an answer which is equal to 1. For the function we have, since we know that f of x is equal to 0 for any number outside our range, right, then it implies that we are only going to work on this range over here. So this will be our lower limit, whilst this is our upper limit. All right, so it means we are going to find the integral of k x squared dx from 0 to 4. Right, we are saying it should be equal to. This is what is going to help us solve for our k. So what do we do now? For this type of integration question, we first of all bring our constant out. That is, we are going to get k. Then we have the integral of x squared for this range dx equals what? 1. Alright, so let's take note of this and then we can go to the next page. Now, we know the integral. So the integral of x squared dx is equal to x cubed over 3. What to do is we increase this by 1 and then divide it also by the exponent as well, right? So if you want a different class for integral, we'll do that another time. But for now, we should know that the integral of x squared dx, or the integral of x squared with respect to x, gives us x cubed all over 3. So if we come back to what we have over here, it simply means we are going to evaluate with our limits. So we have 0 to 4 x squared dx. Take note that our constant is still here, right? Our constant is still there, but then we want to work the integral first. We know the relation between the k and then all this is just multiplication. So let's just work that out, right? So this integral that we are solving now gives us, we have gotten the integral of this one as x cubed all over 3. So since we want to evaluate it over the limit, we're going to write x cubed over 3. Then we now put the limits over there. So our upper and then lower limit. This simply means wherever we see x, we should put what? 4 and then 0. Alright? So we start with the 4, the upper limit minus the lower limit. So for the 4, we have 4 cubed over 3. That is, instead of x, we put our 4 there. Minus cube over 3. That is the value of x. Evaluating this one, we are going to get 4 raised to the power 3 gives us a 64. So 64 all over 3. And we know this over here is definitely going to give us 0. You see? So the integral of all of this one, is what we have solved over here. So coming back to what we have over there, we have k times this that we have evaluated, right? So in actual sense, our integral, which was initially k x squared dx with our limits here, is actually equal to k times what? 64 over 3. And take note that we said it's equal to 1. That is what is going to help us solve for our k. Alright? So we come here and equate all this to 1. So that we have k times 64 over 3 is equal to 1. And we now want to make a the subject. So making a the subject, we can just choose to multiply this by 3 over 64 and multiply this also by 3 over 64, where this 3 now cancels its corresponding 3. Alright, so this 3 here cancels this 3, this 64 divides this, and we'll be left with what? Our k is equal to 1 times 3 over 64, giving us a 3 over 64. Right? So as you can see, that is the value of k. It is very, very simple. Right? So what have we done? First of all, we needed to show that the function we had was what? It was worthy of being a probability, what do you call it? we need to show that the function we had was worthy of being a probability density function. How do we do that? By making sure that at any value of x, we should get a value that is greater than or equal to 0. So that is what we did here. And then secondly, we find the value of k using integrals to do that. And as you can see, our k is what? 3/64. So see you in our next question.